In this lesson, we're going to learn how to calculate molar mass for a chemical compound by looking at its formula. Now, your teacher or textbook might use one of these other names instead of molar mass. But the good thing is, these are all pretty much just different names for the same thing. So what we're going to learn here is going to work no matter which of these things you're talking about. So we'll do a bunch of practice problems, start out with some relatively straightforward examples so you can really get a hang of it, and then we'll look at some ones that are a little bit more challenging as we move on. So by the end of this, you're going to be a total pro at calculating molar mass. Here's our first example, SO2. So to calculate the molar mass for this compound, we need to figure out how many of each type of atom there are in the chemical formula. Okay, so we have an S without anything after it. So that means that we have one sulfur atom, right? When you have a chemical symbol without anything after it, it means you have just one of them. Then we have O2, which means that we have two oxygen atoms here. So one sulfur atom, two oxygen atoms in this formula. Now, we need to figure out how much sulfur atoms and how much oxygen atoms weigh. And we can do that from the periodic table. So we look up sulfur and oxygen on the periodic table, and this is what we find. And these numbers here are how much these various atoms weigh. So now we add these together, keeping in mind how many of each atom we have. So we have one sulfur atom, so I'll do 1 times how much sulfur weighs, which is 32.07, plus 2, because I have two oxygens, 2 times how much oxygen weighs, which is 16.00. Now, you don't really have to do the 1 here because I only have one sulfur, but I just like to do it because I think it sort of makes things more consistent and a little easier. So 1 times the weight of sulfur times 2 plus 2 times the weight of oxygen gives us 64.07. And the units here are grams per mole. Now, what this means is that 1 mole of SO2 weighs 64.07 grams. That's what this grams per mole means. So how much does a mole of SO2 weigh? 64.07 grams. Let's keep going. Okay, C3H8O. As before, we look at the chemical formula to figure out how many of each type of atom we have here. So C3 means we got 3 carbon atoms. H8 means we got 8 hydrogen atoms. And O without anything after it means that we just have 1 oxygen atom. Now, we look up each of these atoms on the periodic table to find out how much they weigh. Carbon is 12.01. Hydrogen is 1.01, and oxygen is 16.00. Now, we add up the weights of these atoms, keeping in mind how many of each atoms we have. So we have 3 carbon atoms, so we're going to do 3 times how much carbon weighs, 12.01, plus 8, because we have 8 hydrogen atoms, times 1.01, which is how much hydrogen weighs, plus 1, because we only got 1 oxygen atom. 1 times 16.00. Multiply these and add them together, and we get 60.11. Don't forget the units, grams per mole. And once again, this grams per mole here means that 1 mole of C3H8O weighs 60.11 grams. This is the amount of grams that a mole of this weighs. Now let's keep going and look at some examples that are a little bit more complex because they have parentheses in them, which can get a little bit tricky. Okay, Ca, and then we have parentheses, NO3, 2. So let's use this formula to figure out how many of each type of atom we have. The first thing we have is Ca without anything after it. So that means that we have 1 calcium atom. Now we have NO3, but it's in parentheses and there's a 2 after that. So what that means is that we have 2 NO3s. Here they are, NO3, NO3. Now, Each of these NO3s has 1 nitrogen and 3 oxygens. But since we have 2 of them, we end up getting 2 nitrogens total and 6 oxygens total. 1, 2, 3, 1, 2, 3. Okay? So that means that total in our formula here, we have 1 calcium atom and then 2 nitrogen atoms and 6 total oxygen atoms, because this NO3 here is in parentheses and we have 2 of them. Now we just do the same thing we've done before. We know how many atoms of each type we have, so we look each atom up on the periodic table and find out how much it weighs. Now we go through the calculations like we've done before. 1 calcium, so we do 1 times 40.08, plus we've got 2 nitrogen, so we do 2 times 14.01, plus 6 times 16.00, because we have 6 oxygens, and we end up with 164.10 grams per mole. And I know this might sound repetitive, but it's really important to keep in mind what this number means. And it means that 1 mole of CaNO32 weighs 164.10 grams. That's how much a mole of this weighs. Let's do one more example with these parentheses, just so we can get the hang of how we do the multiplication here. Okay, parentheses, NH4, 3, PO4. So, how many of each type of atom do we have? Well, this part of the formula tells us that we have 3 NH4s. So, here they are, 1, 2, 3. Now, how many total nitrogens and hydrogens do we have? Well, each NH4 has 1 nitrogen and 4 hydrogens, okay? But we have 3 of these NH4s. That's what this 3 is telling us here. So that means that total, since we have 3 of these, we have in total 3 nitrogen atoms and 12 hydrogen atoms. Okay? So that's what we get from this part, because we have 3 of the NH4s. Now let's keep going with the formula. We got a P with nothing after it, which means that we have 1 phosphorus atom, and then we have an O with 4 after it, so that means we have 4 oxygen atoms. Okay? I'm just going to get rid of this math stuff up here so that it can be a little bit clearer. Okay, and now we know how many of each type of atom we have, so we just pull these up on the periodic table. Nitrogen, hydrogen, phosphorus, and oxygen, and we do the math here. And we do 3 times nitrogen, 14.01, plus 12 times how much hydrogen weighs, 1.01, plus 1, because we only got 1 phosphorus, times how much phosphorus weighs, 30.97, plus 4 times 16.00, which is how much oxygen weighs. And we end up with 149.12. What are the units? Grams per mole, which once again means that 1 mole of NH43PO4 weighs 149.12 grams. This is how much a mole of this weighs. Let's do one more formula for something that's a little bit tricky. We don't see it a lot, but it can be very